Imagine deploying a fully working Azure infrastructure with production-ready Terraform modules from your application code. This isn't a dream, it's Nitric. We've just released support for generating Terraform for Azure, and in this video I'll walk you through how it works from code to cloud in minutes. And as a bonus, I'll use Cursor AI to make a few live changes along the way. Here's a simple Nitric project in Cursor. Under our services folder, our API.ts file defines two basic endpoints, a health check and an echo that returns what you send it. These routes are handled by a standard Express app and wrapped using Nitric's HTTP proxy resource, which makes them deployable to the cloud. In the Nitric YAML file, you can see the default config. This tells Nitric where to find services using glob patterns and how to build them using a standard node Docker file. So here's that Docker file. It's simple and production ready. Now for the good part, I'll create a new Terraform stack for Azure using the Nitric stack new command. I'll use the default stack name and select the Terraform Azure provider. This will generate a new file for our stack. Let's jump into our stack config file. I'll choose the region. I'll pick one close to me, and I'll just auto-complete my org using Cursor. And I'll drop in my subscription ID off the screen. So next, let's run Nitric up. Nitric up does all the heavy lifting. It builds the Docker image, analyzing the infrastructure needs, and generates the Terraform modules using CDKTF. So here we can see the CDKTF.out folder being generated. Inside that folder is the cdk.tf.json file. This is the fully generated Terraform configuration ready to use. So let's take a look at a few modules. The HTTP proxy module provisions an API gateway that connects to our service. You can also find the input variables co-located with the module. The service module handles everything from Docker image builds to container apt hosting, permissions, and role assignments. All of this was generated for us, but still readable, editable, and 100% Terraform. So let's start deploying. First, I'll navigate to the stack, and then I'll run Terraform init. Nice. And then I'll go ahead and run a Terraform apply. So it looks like Terraform plans to add 41 resources, a full cloud stack. Yep, they all look good. And with a quick yes, it's off to the races. Once done, I'll head over to my Azure portal and check out the generated resource group. You can see the full stack created, including API management, container apps, and everything wired up automatically. So I'll grab the URL from the API and let's test the endpoints using curl. Yep, so the health endpoint returns okay, and echo gives me exactly what I expected. So back in API.ts, let's make some changes. I'll open the Cursor agent chat and type use Nitric KV store to manage a to-do list. And I'll give it a reference to the KV documentation. Alright, let's hit enter and let Cursor take over. We can see it is generating a full CRUD implementation using Nitric's KV store, including a properly scoped KV resource with the required permissions. Looks like it's stumbling a bit with some of these TypeScript linting errors, but it's good that it's providing curl examples for each endpoint. So I'll just accept this, and I'll fix up the remaining errors myself. Looks like it's mostly to do with error handling in Express, and returning responses, and we need to return the response correctly for the errors. So let's quickly fix those with Cursor's tab completion. I'll just move the return statements, accept the changes, and we're good. Now that the app has changed, I'll run Nitric up again to regenerate the Terraform modules based on the new code. Then I'll switch back to the Terraform stack. First I'll run Terraform apply just to show that something's changed. Terraform tells me I need to reinitialize, so I'll run Terraform init and then Terraform apply again. So the changes include a new storage account, a storage table for the KV store, updated permissions, and an updated Docker image. So let's go ahead and deploy that. So let's head back over to the Azure portal and verify the new resources. There's our storage account. So back in Cursor, let's start testing the new endpoints. But first, I'll just run the health check to make sure the API is still up. Looks good. Then I'll make use of this Cursor chat and copy the suggested created to do curl command. I'll update the host name to be the Azure API URL and run it. It works! The to-do is saved and returned. Now I'll call the /todos to get all items. There's our new to-do. Then I'll query to-do/ID using the ID from the previous response. Yep, there it is. Now let's delete the to-do using the delete endpoint, and let's quickly check it's deleted. Yep, and the list is empty as well. Everything works end to end. To wrap up, I'll run Terraform destroy to clean up the resources. That's how you go from app code to real Azure infrastructure, generated, deployable, and fully controlled using Nitric. If you want to check this out, head to nitric.io You'll find the GitHub repo and full docs there. And if you found this helpful, please star the repo, it really helps us out. You can also join our Discord community to ask questions or share feedback. Thanks for watching, like and subscribe, and I'll see you in the next one.